This is Samuel with his math people project, and I've robbed a classroom for this real quick, so I have to be kind of quick, so sorry for going fast. But I did Ohm's law. That's this triangle, and this is just an easy way to remember it. It's technically three different equations. So V equals IR, which is voltage, equals current times resistance. That's what the IR and V stand for. And this is just a simple way to remember it. So if you need current, you just cover it up and you get voltage divided by resistance. Or if you need that, you can look at it that way. Or if you need that, you can look at it that way. And just a quick example, if I have 20 volts and 10 ohms, ohms is how you measure resistance, I need to find I, which is my current. So if I need to find I need to use this formula right here. So I just take my volts, which is 20, and then my ohms, which is 10, and then I get 2, which is, one second, which is amps. And yeah, sorry it's so quick, but I've got to get out of this classroom. They said I could use it for like a minute, so that's just a quick example.
Hey, my name is Brian. I'm doing my project on the Wright brothers. I'm in Sebrina Cooper's class, Math 171. Name of mine is First Flight. They were the first people to invent the flying and working plane on December 17th, 1903. And they used math formulas to do it. Now, if you will scroll down with me, you see we have weight, lift, drag, and the thrust. And here you go the formula they use for that, where L stands for the lift generated, D stands for the drag generated, K stands for the coefficient of air pressure, S stands for the surface area, V stands for the velocity, the coefficient of shift is CL, and CD is the coefficient of drag. Now if you'll scroll down, you'll see the formula that I decided to use, that they use as well, where it says the surface area, and you see where lift, it says 0.003 times 512 times 32 squared times 0.515, which equals 891. Now the weight of the person, including the suit and the tie, is 141. Now the total is 745 pounds. So since the lift is higher than the weight, then that makes flight possible once you multiply it together and add it together and subtract it. Thank you for listening.
I'm going to be showing how to graph and solve the supply and demand problem shown in my paper. I have the table right here, and I have already graphed it. It would take a decently long time to graph it, and I go over the time limit. So, as you can see on the graph, the equilibrium is when the price is $4 and the quantity supplied and demanded 300. Anything above that would result in a surplus, as shown here. The surplus. Anything below it, shortage, shown right here. So if there were to be I'm also going to show what happens with a shift, either supply or demand. So there's a shift in the curve whenever there is something that changes sides the quantity supplied and the price. So like advancement technology. I'm going to graph to shift now. Like if there was some kind of something that made making burgers more efficient. Just as an example. That's just a quick graph. Not very accurate, but quick. So now the equilibrium has changed to be at around $3.50 and 350 supplied and demanded.
Hey, my name is Ethan, and I'm here to talk about drugs, specifically medication. So we were supposed to do something with life and math, and I chose medication. Since my mother is a nurse at Daymont across the street, I decided to do that. Now, one of the formulas they use for describing medication is either A, demand over half, or the more precise and most preferred method, ratio and proportion. Ratio proportion is what I have here. For for example, you got Med A, which is 500 milligrams per 10 milliliters, and you have Med B, which is 150 milligrams per X ml. So you gotta solve for X. So basically, you write it like this. You replace per with the two little dots in the equation. So the first thing you want to do is get rid of all the symbols because you don't really need that. That's just gonna confuse you. Even though I figured this out in like a minute, it's going. But no. Anyway, you remove that and then you multiply. The first thing I have to address is you don't multiply 150 times x. You can't do that because it's gonna mix up the entire problem. What you do is you multiply 500 to x and then 10 with 150. So you get it right here. 500x equals 150 times 10, which is equal to 1,500. You have x by itself. 500 divided by 150. You have 500 divided by 500, and then 115. Oh, no, not one. 1,500 divided by 500. That will give you the x will equal 3 mLs.
Looking for a color is similar to solving an equation. I'm looking for a color purple at the end of this equation. 2.8 is my light blue dye. 1.2 is my red dye. And 3.2 is a darker blue dye. First, I want to subtract my 2.8x into my 3.2x. In the end, this should give you 0.4x. Bring down 1.2. Now you have 1.2 equaling 0.4x. Divide 0.4 into 1.2. Your end result should be 3, or the purple that you're looking to achieve at the end of this equation.
Hello, my name is Nicholas Nordberg, and I chose to do my Math and People presentation on Elon Musk. As it says, Elon Musk here, a lot of people know, he's the wealthiest man in the world. He's gone on to create several different companies, one in which actually explores space. So this is where my presentation will end up kind of connecting how math would be very relevant for his kind of world. Elon Musk, like I said, very smart guy. He actually ends up using Newton's laws of motion, but only typically like the first or second one, as do a lot of scientists for that matter. Any scientist that wants to send something out into space. So to get back to basics, understanding what it takes to launch something into space, that's where the first part, or the first law rather, of Newton's laws comes into effect. It's understanding that something that either one is already on a path or one that is sitting stationary can't deviate unless an outside force directly goes and stops it from continuing whatever it's doing, whether it's sitting still or continuing on its course. The next part of it, the second part, is understanding, and typically there would actually be like a horizontal part of this, but when it comes to rockets, you only need the vertical, not the horizontal, which is why I ended up using this. Well, here it is right here without the actual horizontal part. But what it is you take the net vertical force, and you have to take the thrust and the weight with the mass and times it by acceleration in order to be able to get the proper thrust to be able to launch the rocket and actually have the rocket stay up and go into orbit. And in here, just in case, I made sure I put in a couple extra little pieces in here, such as the T and the equation stands for thrust, weight, net vertical force. Thank you. Hope you enjoyed.